well. Today we are going to continue with our derivations. Guys, this is the last week going on. So what I have decided, because after today's lecture, we need 2 more hours of lecture because we need to study theory of theories of failures, and that lecture will require 2 hours. So I will see whether I can arrange additional class, okay, because we are also having currently we are having end semester exams of first year and final year, and we have like other teachers, I also have exam duties. So I need to see that how can we have this 2 hour lecture. Other option is that instead of having an online class, when you guys will come on campus for your psychomotor performance, we can have 2 hour lecture on campus, and the advantage of that lecture will be we will also have some interaction. Okay? Like particularly I want to have some interaction with A section because with you guys, I will have a lot of interaction. Will have a lot of interaction during the psychomotor week, because you will be doing experiments with me, performing experiments with me. With C and D section, I have interaction because I have taught them steel structures in fall. So what I was thinking that if it's possible, like with Dr. Numan, he will have additional lectures. So what I was thinking to have 2 hours on campus class during the psychomotor week to cover theory of failure. So if it is fine, please let me know. And if you have any observation or anything, you can let me know now. No objection. So it means it's fine with you guys. Uzair?
Okay, sir.
Online, because I also want to have like interaction with the other sections as well, because I have taught them almost like 6 months, and एक दफा जो है चेहरा तो पता होना कि ये अपना student है कि नहीं, just like this. ठीक है? So guys, today we will sorry, first of all, sorry for the delay. Today's delay was that there was one official meeting. That meeting started at 12 o'clock and it finished at 10 minutes to 2. So then I came back to the department and then I have just started the class. So if you guys are ready, we should start our class now.
Yes, sir.
Okay, Bismillahirrahmanirrahim. Let's start with our today's lecture. Start recording. Okay. So last time we have, if you recall, last time we have done these two relationships, material property relationships we had started. And in that case, in material property relationships, we had derived the equation for generalized Hooke's law. These three equations we have derived, and then Uzair shared these derivations with us, and then I shared those derivations with other sections as well. Along with that, last time we have also derived the equations between the shear stress and shear strain, normal stress and normal strain. Okay, normal stress and normal strain, shear stress and shear strains. Okay, so continue with these expressions. We will derive the relationship. Basically, we want to derive the relationship between modulus of elasticity modulus of rigidity. G is your modulus of rigidity. Mu is your Poisson's ratio. Mu is your Poisson's ratio. So this relationship we have to derive, that is G is equal to E over 2 times 1 plus mu. 2 times 1 plus mu. So one way, I think we will come to the book later on, because in the book they have like shortlisted many of, like they have omitted many of the steps. So it's really many steps are missing and it's a bit difficult to understand at first. So first I will explain to you with my lecture notes and slides. So let's start it. To derive this relationship, that is to derive the relationship between modulus of elasticity, rigidity, and Poisson's ratio, G is equal to E over 2 times 1 plus mu. To derive this relationship, we have to consider an element of the material which is subjected to pure shear stress. Okay, ji? So now when we say that the element needs to be subjected to pure shear stress, we are basically saying that sigma x should be 0, sigma y should be 0, and sigma z should be 0. Okay? So to derive this relationship, we are going to consider an element which is just subjected to pure shear stress. So this is your element which is subjected to pure shear stress, means there is no normal stress is acting on the element. Okay? So we just have shear stress. ठीक है जी. So now sigma x is 0, sigma y is 0, and sigma z is 0. So after applying the equation, so this equation is, if you recall, this equation is for the computation of the principal stresses. Computation of the principal stresses. So major principal stress sigma 1 is equal to sigma x plus sigma y over 2 plus under root sigma x minus sigma y over 2 square plus tau xy square. Sigma 2 is sigma x plus sigma y over 2 minus under root sigma x minus sigma y over 2 square plus tau xy square. ठीक है जी. Now when you will put the value of sigma x and sigma y both equal to 0, ठीक है जी, they are all these, both these values are 0 because your element is subjected to only shear stress. ठीक है जी. So sigma x 0, sigma y 0. So what will you left? You will, this will be 0, this will be 0. So you will be left with under root tau xy square. And if you take the under root of tau xy square, you will get sigma 1 as plus tau xy and sigma 2 as minus tau xy. Any questions about this part?
No, sir.
Okay. Now you have maximum stress sigma max as tau xy, fine, and minimum stress sigma minimum as minus tau xy. ठीक है जी. Now proceed further. So this element means this one. This element which is subjected to only shear stress, and the maximum and the minimum stresses are tau xy and minus tau xy. So this element must be oriented at an angle of theta 45 degrees counterclockwise from the positive x-axis. So this is your positive x-axis and this is your angle, or you can say x dash axis, which is oriented at an angle theta which is 45 degrees, and this theta is your orientation of the principal plane. So about this x dash axis you have maximum stress, that is tau xy, and about y dash axis you have minimum stress, that is minus tau xy, and you can see this is compressive, so that's why tau xy, okay, minus tau xy, compressive stress. Now this element must be oriented theta p1 is equal to 45 degrees counterclockwise from the x-axis if the three principal stresses are sigma maximum is tau xy, sigma minimum is minus tau xy, and sigma intermediate is 0. Now, let me tell you one thing. This one, we are considering biaxial stress state. We are considering biaxial stress state, ठीक है जी, in which you have only two normal stresses, sigma x and sigma y, ठीक है. So in that case, your two principal stresses will be, major principal stress will be sigma maximum and minor, or you can say minimum minor principal stress will be sigma minimum. However, in general state of the stress where you will have three normal stresses, sigma x, sigma y, and sigma z, in that case you will have three principal stresses, sigma maximum, sigma minimum, and sigma intermediate. Because we are not having like all our study was focused on biaxial stress state, so we were not having uh, three principal stresses, we were having two principal stresses. But in the case of general triaxial stress case, you will have three principal stresses, maximum intermediate stress, maximum principal stress, intermediate principal stress, and minimum principal stress. So maximum principal stress is tau xy as we have calculated earlier. ठीक है जी, maximum is tau xy, minimum is minus tau xy. Fine. So intermediate is 0. So intermediate is 0 because in overcase, because there is no sigma x, there is no sigma z, so intermediate principal stress is 0. Now what we will do, we will put the value of sigma max, ठीक है, sigma minimum, ठीक है, sigma max is about the x dash axis, sigma minimum is about the y dash axis, and sigma z is 0. ठीक है जी. Now this is the generalized Hooke's law equation. ठीक है, let me show you this. This is the generalized Hooke's law equation, that is epsilon x is equal to 1 over e modulus times sigma x minus mu times sigma y plus sigma z. ठीक है जी. Now when I come back to this equation to get the maximum strain, ठीक है जी, when I will put the values of sigma x as sigma maximum, which is your major principal stress, or you will put the value of sigma y, which is your minimum principal stress, ठीक है जी, you will get epsilon x as epsilon maximum. So substituting the value of sigma x, sigma y, and sigma z, ठीक है जी. So sigma x is equal to tau xy, so I'm going to put sigma x as tau xy. Sigma minimum, this is basically your stress about the y axis, so I'm going to put this as sigma y as minus tau xy. Sigma z, the stress is basically about, principal stress about z is 0, so I'm going to put sigma z value as 0. The principal strain epsilon maximum, the principal strain epsilon maximum can be related to the shear stress now. So sigma x is tau xy, sigma y is minus tau xy, sigma z is 0. So sigma maximum, epsilon maximum is equal to tau xy over e minus and this minus will become plus mu times tau xy over e minus times sigma z is 0. Sigma z is 0. So now after simplification, epsilon maximum epsilon maximum is equal to tau xy over E, that is taken as common. So this will become 1, minus minus will become plus, 1 plus mu. So you get epsilon maximum, the principal strain, that is tau xy over E times 1 plus mu. Everyone please solve this up to this point and let me know if you need any help. Is this point up to this point clear?
Yes, sir.
Yes, sir.
Okay, so now you got epsilon maximum is equal to tau xy over E times 1 plus mu, and this is your equation number A. Okay, ठीक है जी, now proceed further. Sorry. So now this strain basically now we want to simplify it. ठीक है जी, अब how we are going to simplify it? That's you have a strain, ठीक है जी, which is basically epsilon maximum. This strain is your epsilon maximum. So this strain which deforms the element along the x dash axis, ठीक है जी, can also be related to the shear strain gamma xy. ठीक है जी, so this is your epsilon maximum, ठीक है जी, and that will be about the x dash axis. ठीक है, sigma maximum is along the x dash axis, sigma minimum is along the y dash axis. So this strain which deforms the element along the x-dash axis can also be related to the shear strain. Now we know that over element is subjected to shear stress only. So normal stress is sigma x, sigma y, and sigma z are 0. So when we will put these values to calculate the normal strain using the generalized Stokes law equations, so we know that epsilon x is equal to 1 over E times sigma x minus mu times sigma y plus sigma z. ठीक है जी, and epsilon y is 1 over E times sigma y minus mu times sigma x plus sigma z. We have sigma x 0, sigma y 0, sigma z 0. So this equation will give me epsilon x as 0. And this equation sigma y x z 0. So this equation will give me epsilon y 0. ठीक है जी, so epsilon x is 0, epsilon y is 0. ठीक है जी. Now substituting these results into the strain transformation equation, ठीक है जी. So now to calculate the principal strains, we are using the equation to calculate the principal strains. Now epsilon 1 2 is equal to epsilon x plus epsilon y over 2 plus minus under root epsilon x minus epsilon y over 2 square plus gamma xy over 2 square. So we have epsilon x, epsilon y 0. So this factor is 0, this factor is 0. So you are left epsilon 1 2 is equal to plus minus under root gamma xy over 2 square. ठीक है जी. Now when you will this square root will cancel out with square, so you will get epsilon 1 that is equal to plus gamma xy over 2. Epsilon 1 is equal to plus gamma xy over 2. So epsilon 1 is your basically the maximum. ठीक है जी. Always we know that the larger value of the principal strain will be epsilon 1 and smaller value will be epsilon 2. So epsilon 1 is equal to epsilon maximum, and that is equal to gamma xy over 2. Gamma xy over 2. So now we have related the principal strain with the shear strain. Now further applying the Hooke's law. Hooke's law is gamma xy shear strain. Gamma xy is equal to tau xy over g. So this is the equation which we have derived last time. Gamma xy is equal to tau xy over g. Fine. So we can basically replace now gamma xy. So from here you can see gamma xy will be equal to 2 times epsilon max. Gamma xy will be equal to 2 times epsilon maximum. So gamma xy will be equal to 2 times epsilon maximum. So this equation will now become epsilon maximum is equal to tau xy over 2 times 1 over g. So this is now over equation B. This is now over equation B. Everyone fine with this up to this point? Clear here? This one after maximum is equal to tau xy over 2g.
Yes, sir.
Okay. Now what we are going to do, we will equate these two equations equal. This equation A and equation B. So equation A is epsilon maximum is equal to tau xy over e times 1 plus mu, and your equation B is epsilon maximum is equal to tau xy over 2g. So equating these two equations, you will get tau xy over 2g, tau xy over 2g. This is your equation B, and tau xy over e times 1 plus mu. That is your equation A. Now we will simplify this equation. ठीक है जी, we will simplify this equation and we should get this expression. Tau xy will cancel out. So E is equal to 2g times 1 plus mu. E taken this on this side and 2g taken on this side. So E is equal to 2g over 2g times 1 plus mu. So G will be equal to E over 2 times 1 plus mu. Is this clear? Guys, please take 1-2 minutes and solve this. And if you have any query, please let me know. Is this clear? If you have any query about this derivation of modulus of elasticity, rigidity, and Poisson's ratio, please ask me.
No, sir.
इस इक्वेशन को यूज कैसे करेंगे? अगर let's say I ask you to calculate the modulus of rigidity of steel pipe, ठीक है जी, having modulus of elasticity 200 gigapascal and Poisson ratio 0.3. तो जरा modulus of rigidity तो बताएं. कैलकुलेट करें, मुझे बताएं जरा.
Sir, 76,923.07.
923.1. तो ये क्या आंसर यूनिट्स क्या है इसके 76923 के this is megapascal, so you will divide it by 1000 to get the answer in gigapascal. तो gigapascal में आंसर आएगा 76.9. Clear?
Yes, sir.
Yes, sir.
If it is clear, then we are proceeding to next. ये derivation उन्होंने बड़ी slides, we don't need it now. Okay. Now, next derivation which we have to do, that is basically related to the dilation and the bulk density. That is related to dilation. That is related to dilation and bulk density. The fourth derivation, and that is basically our last derivation. So before that, we have some definitions to study. So Poisson's ratio, it is the ratio of lateral strain to the axial strains. Okay, Poisson's ratio, the P of Poisson should always be capital. जब भी आप लिखें तो इसको capital लिखना है because it's a name. So Poisson's ratio, it's the ratio of lateral strain to the axial strains. Its value varies from 0.2 to 0.35, and for steel, generally its value is 0.3. Okay, then comes the dilation. Dilation is change in volume per unit volume. ठीक है, dilation क्या है? The change in volume per unit volume of any material is called as volumetric strain or dilation. ठीक है जी? My PhD was related to this topic, dilation. Basically, what happens? You have a concrete cylinder. ठीक है जी? In PRC1, you are studying concrete, and when you say कि जी unconfined concrete, you apply the axial load, so corresponding axial stresses and axial strains will be produced in the concrete. ठीक है जी? And after some time you will see the bulging out of the concrete. ठीक है जी? The concrete bulges outward. Outward bulging क्या होती है? You are applying the axial strains which are compressive. ठीक है जी? Along the longitudinal direction you have axial strains which are compressive. So laterally tensile strains are produced, which means the elongation. So there will be the concrete will bulge outwards. ठीक है जी? So now dilation is like the outward increase in the volume. That what we do, ठीक है, there is one very positive advantage of this dilation. So if you confine the concrete, ठीक है जी, if you confine the concrete with some FRPs, FRPs हैं कि fiber reinforced polymer sheets हैं. Just like if you roll something around your concrete, so what will happen? You will apply the load. ठीक है जी? You will apply the load, so that is basically your axial stress. So correspondingly, axial stresses, axial strains will be produced. Now, due to the Poisson's ratio, we know lateral strains will be produced. So concrete will dilate. ठीक है जी? Its volume is increasing. As the concrete will dilate, now we have put FRP sheet around it. So this concrete will exert pressure. ठीक है? The concrete will exert pressure on the FRP. ठीक है जी? And this pressure will continue to increase. As the load is increasing, axial stresses are increasing, axial strains are increasing, correspondingly lateral strains are increasing, so the volume of the concrete is increasing. And this like they are putting the pressure on the FRP. Now a stage will come, ठीक है जी, a stage will come that according to Newton's third law, that to every action there is equal and opposite reaction. So what will happen? FRP sheet will start confining the concrete. ठीक है जी, FRP sheet will apply the opposite stresses to the dilation and it will start confining the concrete. ठीक है जी, and your concrete will start taking the load. ठीक है, तो let me draw one figure. One second, it's just downloading. लें जी, excellent हो गया जी. तो we have already drawn the figure जी वाली. अब हमें सिर्फ stress strain draw करना पड़ेगा. So this is your stress, this is your strain. ठीक है जी, normal stress strain concrete, ठीक है जी, this is the stress strain curve which you have studied. ऐसे ही है, आपने यही पढ़ी है ना अभी in PRC1.
Yes, sir.
This is your concrete strength, FC prime जिसे आप कह रहे हैं, ठीक है जी, and correspondingly you have value of the strain which is for normal strength it is 0.003. ठीक है. Now advantage of FRP confinement मैंने जो आपसे बात की, that is you will have this behavior and from this point onwards, ठीक है जी, FRP will activate, FRP will activate, ठीक है जी. Let me change the color. FRP will activate and you will have this behavior, ठीक है जी, you will have this behavior. You can see now your confined concrete strength will be somewhere here. So this is due to the confinement, ठीक है जी. You will see this increase in concrete strength and increase in this value of strain. ये देखिए आपका strain भी increase हो गया and your stresses have also increased. So this is now confined concrete strength. This is confined, CONFINED, confined concrete strength. This is your unconfined concrete strength. You can see after reaching the peak axial stress, and there is dilation, and afterwards it starts to fail. इधर क्या हुआ है? FRP has become effective from here, and it provides the confinement to the concrete, and concrete started to take the extra load. So the failure is now at this point. ठीक है जी. So this is basically for this BS level. This, if you can just understand this simple phenomena up till here, should be okay. Is this clear?
Yes, sir.
ये वाली फिगर क्लियर है? ये आपको ये ड्रॉ
Yes,
कर
sir.
लें. It will be helpful for you in the future as well. Okay, ji. Now dilation is, we have defined the dilation as the change in volume per unit volume of any material. ठीक है जी. Dilation is also called as volumetric strain. Change in volume per unit volume of the material, it is called as volumetric strain or dilation. So bulk modulus is, now just like elastic modulus, you also have bulk modulus, which is also called as the volume modulus. So bulk modulus is ratio of volumetric stress to volumetric strain is called as bulk modulus. So bulk modulus is ratio of volumetric stress to the volumetric strain is called as bulk modulus or volume modulus of elasticity. Modulus of rigidity is ratio of shear stress to shear strain, ठीक है, और the slope of shear stress strain curve from 0 to proportion limit, ठीक है. Modulus of elasticity आपकी क्या थी? Ratio of axial stresses to axial strain or the slope of axial stress strain curve up to from 0 to the proportion limit. That will give us the modulus of elasticity. ठीक है जी. मॉडुलस ऑफ रिजिडिटी वैल्यू वेरीज फ्रॉम, ये गलत लिखा हुआ है, मेगा पास्कल्स नहीं है, गीगा पास्कल्स है. ठीक है, 60 to 80 गीगा पास्कल्स, यू हैव फाउंड 76.9. So modulus of elasticity is 200 gigapascal. Few values, these are few values which you need to keep in mind. ठीक है जी. So dilation is change in volume per unit volume of the material. ठीक है जी. Also known as volumetric strain. Bulk modulus is volumetric stress to volumetric strain. ठीक है जी. यानी कि bulk modulus बेसिकली आपका क्या बना? Volumetric stress to dilation. क्योंकि volumetric strain तो आपका dilation है. ठीक है, is called as bulk modulus. Modulus of rigidity, ratio of shear stress to shear strain. Modulus of elasticity, ratio of axial stress to axial strains. Let's start with our equation. ठीक है जी, the equation which we want to derive for dilation and the bulk modulus. So when an elastic material is subjected to normal stress is आपके क्या है? Sigma x, sigma y, sigma z. ठीक है जी. Its volume will change. Of course, its volume will change. We have studied this earlier over here. This figure, axial stresses are acting. ठीक है जी. So what have resulted? There is elongation along x, y, and z. So there is what you say, a volume change. So when an elastic material is subjected to normal stress, its volume will change. Its volume will change. So now consider a volume element subjected to principal stress sigma x, sigma y, sigma z, and initial sides, dimensions of the sides of an element are dx, dy, and dz. ठीक है जी. So principal stresses are what you say, this normal stress is sigma x, sigma y, and sigma z are acting on the element, and element has original dimensions dx, dy, and dz. So then after the application of the stresses, the sides, because they are elongated, so after the application of the tensile stress, the sides became dx become 1 plus epsilon x times dx, dy becomes 1 plus epsilon y times dy, dz becomes 1 plus epsilon z times dz. Up till this point, it's okay? Is it okay?
Yes, sir.
Okay. Now, the change in volume. Change in volume क्या है? New volume minus the original volume. ठीक है जी. Now, new volume will be, change in volume will be new volume minus the original volume. New volume is 1 plus epsilon x times dx times 1 plus epsilon y times dy times 1 plus epsilon z times dz minus the original volume, that is dx, dy, and dz. ठीक है जी. Now This point okay? This point, change in volume is new volume minus the original volume. Now we know that over strains epsilon x, epsilon y, and epsilon z, over strains are in micro strains, means their values are 10 raised per minus 6. So when you multiply epsilon x with epsilon y, okay, when you multiply epsilon x with epsilon y, the value will become somewhere 10 raised per minus 12. Okay? So when you will solve this equation, epsilon x times epsilon y times epsilon z, these values become very small. So already 10 raised to minus 6, when it multiplied with another 10 raised to minus 6, it becomes 10 raised to minus 12. So neglecting the products of the strains, ठीक है जी, epsilon x times epsilon y or epsilon y times epsilon z, ठीक है जी. So neglecting the products of the strains, since the strains are very small, since the strains are very small, we have change in volume now. Epsilon x plus epsilon y plus epsilon z times dx, dy, and dz. Is this point clear?
Yes, sir.
So change in volume is equal to epsilon x plus epsilon y plus epsilon z times dx, dy, dz. ठीक है जी. So over change in volume is this one, epsilon x plus epsilon y plus epsilon z times dx, dy, dz. Now we know that the change in volume, the change in volume per unit volume is called as the volumetric strain or the dilation. So change in volume is epsilon x plus epsilon y plus epsilon z times dx, dy, dz. And your volume is dx times dy times dz. So that will cancel out, dx, dy, dz will cancel out from the numerator and denominator. So over volumetric strain or the dilation, okay, over volumetric strain or the dilation, it becomes equal to epsilon x plus epsilon y plus epsilon z. ठीक है जी. Now it means your volumetric strain is the sum of the three strains in x, y, and z direction. ठीक है जी. Now we have studied earlier that by comparison, the shear strains will not change the volume, rather they will only change its, you can say they will only result in the deformation of the shape. ठीक है जी. It will not change the volume, it will just result in the deformation of the volume. ठीक है जी. So by comparison, the shear strains will not change the volume, rather they will only change its rectangular shape. Okay, now if we apply the Hooke's law, generalized Hooke's law equation, we say these equations. अब हमने, what we are going to do, we have these three equations. Epsilon x is equal to 1 over e times sigma x minus mu times sigma y plus sigma z. Epsilon y is equal to 1 over e times sigma y minus mu times sigma x plus sigma z. And epsilon z is equal to 1 over e times sigma z minus mu times sigma x plus sigma y. We will put these three values, ठीक है जी, in this volumetric strain equation. ठीक है जी, epsilon x value, epsilon y value, epsilon z value, and then we will simplify. We should get the equation volumetric strain or the dilation as 1 minus 2 times mu over e times sigma x plus sigma y plus sigma z. ठीक है जी. So if you have any query up to this point, equation A, please let me know. Is this clear?
Yes, sir.
Okay. Now further. Further, we have that when a volume element of material, this is now further part of the derivation. When a volume element of the material is subjected to uniform pressure of liquid P, ठीक है जी, when a volume element of material is subjected to uniform pressure of liquid P, the pressure on the body is same in all the directions. ठीक है जी? You have seen when there is an element submerged, if the water is acting, it will exert the pressure on all three sides equally. ठीक है जी? And that pressure is compressive. ठीक है जी? It is trying to squeeze the element. ठीक है? Reduce the element or contract the element. So when a volume element of material is subjected to uniform pressure of the liquid, the pressure on the body is same in the all directions and perpendicular or normal to any surface in which it acts. Since the shear stresses are not present, as the shear resistance of the liquid is zero. ठीक है जी? So now the state of hydrostatic stresses requires that the normal stress to be equal in all directions. That is, sigma x should be equal to sigma y, that is equal to sigma z. And all these stresses are equal to the hydrostatic pressure P. ठीक है जी? Uniform pressure of liquid P. And why we are having negative sign? Because it is compressive in nature, trying to squeeze the element. Now we will put this equation B, substitute equation B in equation A. Equation A is this one, epsilon E, this E is equal to 1 minus 2 times mu over E. Sigma x is minus P, sigma y is minus P, minus P. So minus 3P. ठीक है जी? So then after rearranging, you should get this equation, substituting equation B in equation A. We get P over E. ठीक है जी? P is your uniform pressure. ठीक है? E is your dilation. ठीक है? E आपका क्या है? E is your dilation or the volumetric strain. Fine. And this is pressure. Pressure is basically your stress. Pressure is basically your stress. ठीक है?
Yes, sir.
ठीक है जी? So P over E is equal to E over 3 times 1 minus 2 times mu. ठीक है जी? P over E is equal to E modulus of elasticity over 3 times 1 minus 2 times mu. Everyone is getting this equation. Take your time and get to this point and let me know. When you reach to this point, do let me know. Okay. Now, since this ratio P over E is similar, ये क्या है आपका normal stress? Basically, it is stress over dilation, volumetric stress to volumetric strain, basically. So, since this ratio P over E is similar to the ratio of linear elastic stress to the strain, which defines the modulus of elasticity, The term this on the right is called the volumetric modulus of elasticity or the bulk modulus. And this P over E, stress over volumetric strain, is represented by K, bulk modulus. So this equation will simplify to K is equal to E over 3 times 1 minus 2 nu. Okay? Note that for most metals, we know that Poisson ratio is 1 over 3. Poisson's ratio is 1 over 3. ठीक है जी. So K will be equal to modulus of elasticity. So if I put 2 times 1 over 3, तो ये हो जाएगा आपका 2 over 3 हो जाएगा. 2 times 1 over 3 will become 2 over 3. So 1 minus 2 over 3, this will become 1 over 3. 1 over 3 into 3 will become 1. ठीक है जी. So for most metals, Poisson's ratio is 1 over 3. So K will become equal to modulus of elasticity. K will become equal to modulus of elasticity. So if a material existed that did not change its volume, ठीक है जी, then change in volume will be 0, and resultingly your volumetric what you say strain will be 0 and your dilation will become 0, and K would have to be infinite. ठीक है जी. So this value basically this is now bit conceptual, higher conceptual कि ये होता क्या है basically during the dilation. The Poisson's ratio also changes. It does not remain constant. But at junior classes, we just keep it simple. We say over Poisson's ratio throughout the test remains the same. Okay, but in actual, it does vary. Fine. So during yielding, no actual volume change of the material is observed. So you can say maximum value of Poisson ratio at this level, we can just limit it to 0.5. So that was all for today. Basically, today I wanted to cover these two derivations. And now, inshallah, you guys will come on campus on Monday. ठीक है, Monday को आप inshallah यहाँ पे होंगे. So hopefully I will see you guys here. Over paper is mid paper is like next to next Monday. ठीक है, the structure mechanics paper is next to next Monday. I think it will be on 12th of July. And after that, we will have 3 weeks of psychomotor performance. And during that psychomotor performance, we will arrange a lecture in which we will study theory of failures. And then we will have end term exam. If you need any help, assistance in solving any numerical which I have shared with you, you can contact me via email or via, you can say, this WhatsApp. So I'm always available. So if you need any help, assistance, please feel free. This subject is very much scoring, so I am expecting you guys to do very well. ठीक है जी. और वैसे भी आप लोगों का जो सुना है वो तो यही है कि आप लोग सेक्शन जो है बी नंबर तो काफी लेते हैं. Any questions?
No, sir.
If no question, then thank you very much for your time, and inshallah I will see you on campus, and we will have 3-4 weeks of, not 3-4 weeks, we will have 5 weeks of interaction in the coming days ahead. ठीक है जी. Take good care of yourself and see you on campus on Monday in the exam duty inshallah. ठीक है.
Yes, sir.
Inshallah.
Okay guys, take care and all the very best. Thank you.
Thank you, sir.